Systems of equations with quadratics. In this concept, we're going to work with systems of equations like we did earlier in Algebra 2, but this time we won't only have lines. We're going to also have quadratics included. A solution to a system is a point, or it could be multiple points. When graphed, solutions are where the two functions intersect. So here's an example of three graphs. The first graph with the orange quadratic and the blue linear function never cross, so that would be no solution. In the second graph, our quadratic and our linear touch just one time at the point 2, -3, so it's got one solution. And the third graph has two solutions because my graphs cross each other twice. It's not possible to have more than two solutions. Like we couldn't have these graphs crossing 3 times. In this first example, we're going to solve the system by graphing. So notice the first equation that I have is quadratic because I have a squared, and the second equation is linear. It's in the form y = mx + b. Let's graph that one first. So the way we graph this is we start with our y-intercept, our b value, which in this case is -2, and then we do our slope from there. Our slope is 1/1, so we're just going to go up 1/1 all the way to the right and back towards the left. Now my other graph, if you recall, we can graph using transformations. So I'm going to look and see what the -2 does and the -6, which we know that -2 inside the parentheses means it's going to go right 2, and a -6 on the outside means it's going to go down 6. So the vertex of my parabola is going to be down here at 2, -6. It went right 2, down 6 from the origin. And now I kind of have 2 free points anytime I'm graphing a quadratic. It's just up 1/1 on both sides. And then I know I'm going to need to find more points because I'm not really sure where my quadratic is going to cross my linear function. I can't just draw my quadratic right now and call it good because I'm not going to probably intersect at the right spots. So we're going to find more points by plugging in values for x and getting out a value for y, and that'll be a point. First of all, I notice that the x values on either side of my 3 points are either 0 or 4. I think plugging in 0 is way easier. So I'm going to plug 0 into the equation, and I get out -2. So that means that we have a point at 0, -2. I know I can also mirror it on the other side, so I've also placed a point at 4, -2. So I still need to find more points because notice if I were to draw my quadratic, I know I would intersect at that one spot where they're already crossing, but over to the right, I'm going to intersect somewhere as well. I've got to figure out where that is. So now I can either plug in -1 or I can plug in 5. Just need to plug in one of them because they will be symmetrical to the other side. So let's plug in 5. I said -5, I meant +5. So now we have the point 5, 3. And notice I see the 2 places that my graphs are going to intersect, so I can go ahead and draw my quadratic. So my final answers for this system are 0, -2, and 5, 3. So that's my final answer. Make sure you always state that. Don't just graph the 2 functions, but write the answer also. For the next example, we're going to solve using substitution. So recall that means that we're going to solve for one variable, and in this case we're going to solve for y. And then we're going to plug it into the other equation and solve for x. So let's start by taking the top equation, and we're going to solve it for y. I'm going to add the y to the other side, and then subtract the 1 over. Some of you can probably do that in your head, and that's great. You don't have to show the work for that. Now I'm going to take what y equals, which is x² - 1, and I'm going to plug it into the other equation for y. So let me write my second equation now, but I'm going to plug x² - 1 in for y. Next, I have an equation that only has x's in it, so I'm going to solve this. First of all, x squared plus 2x squared is going to give me 3x squared. And then if I add the 1 over, I get 0 on the left side. Divide both sides by 3. Square root, and I get x equals 0. So since I only got one value for x, I know that I'm only going to have one answer here. Sometimes we'll get one answer, or sometimes we might get two. We could also get none. So this isn't my final answer. I told you before that answers are points. So this is the x coordinate of my point. I need to find the y coordinate now by plugging 0 in for x in one of my equations. I'm going to use y equals x squared minus 1. Plug in 0, we get out negative 1. So my final answer is the point 0, negative 1. Now on all of these algebraic problems where we're solving using substitution, you can always check your answer. So I've taken both the equations I was given, and I plugged in 0 for x and negative 1 for y, and I confirmed that I got true statements. So you can do this on every single homework question, every single quiz or test question, and always make sure that you have the right answer. Example 3, we're going to try the same process again. So let's take the bottom equation and solve for y, and then take what y equals, which is negative x plus 5, and plug it in for y in the other equation. Now I know I'm going to have a quadratic to solve because I have an x squared here, and I can tell it's going to be a trinomial that I'm going to need to factor. So I'm going to have 3 terms here. So draw your x to set up. Remember, a times c goes in the top, which is 4. B goes in the bottom, which is negative 5. And I want to find two numbers that multiply to 4 and add to negative 5. So we're going to rewrite the middle term using negative 1x and negative 4x. Draw a line down the middle, pull out a GCF from the first two, pull out a GCF from the second two, rewrite our final answer, or our final factored form, and then solve it. We're going to get x equals 4 and x equals 1. I got that by setting those two factors equal to 0 and solving. So since I have two values for x, I know I'm going to have two answers. I'm going to have the point 4 comma something and 1 comma something. The way that I find out what those y values are is I'm going to plug 4 in for x into one of my equations and plug 1 into x to one of the equations to see what we get out. Let's start with plugging in 4. And I'm going to use the red equation where y is solved for. If I plug in 4, I get out 1. So that's the point 4 comma 1. And now let's plug in 1. It was kind of a coincidence that I got 2 points that were reverse of each other, but those are my two answers, 4 comma 1 and 1 comma 4. Again, we can check ourselves by taking these points, plugging them in for x and y in our equations, and confirming that we get true statements. All right, this one we already have y solved for in the bottom equation, so you're just going to take the negative 3x minus 3 and plug it into y in the top equation and solve. So go ahead and pause your video, try this one on your own, and then restart it to see my answer. This factoring was a little bit different. We had 5x squared minus 5x, so we're just pulling out the GCF, and we get x equals 0 and x equals 1. In the end, our two answers are 0, negative 3, and 1, negative 6. Try this independent practice problem as well. Pause your video and restart it to see my answer. I got negative 3 comma 4 and 1 comma 0.